get to talk about the toys. This is actually the static model. Don't worry, the test at the end of the presentation is open book. But in reality, I'm going to be talking about this model in sections. There are 4 key areas that I'm going to follow up on the slides in a lot more detail, and that's really where the meat of the understanding needs to be. The first section is the area that has been referred to by my fellow consultants from Spark, having to do with the fact when you have a difference that is positive towards the revenue side versus the revenue and the cost, that plant potentially makes money in a particular period. Each one of these rows represents one of the 28 periods that we did the analysis against. This model can be used manually or automated. You can actually have somebody plug in these numbers and affect the model and see what the resulting output would be. Or you could use one of the Excel tools that we use to illustrate that purpose. So in this case, it is these 2 areas here that represent the revenue and the running costs that are the primary inputs to the model. One area, however, that is vital and has the most complicated aspects of the model is what happens when you start up. As indicated earlier, there are startup costs involved. NYPA asks us to look primarily at the startup cost, and for this version of it, not look into the shutdown costs. So that's what's currently built into version 1 of this model. And this illustrates the 2 cases of what I've captured on the screen where we actually decided to have a startup. And this is the important point. At the point we went from a 0 operation, which is what this column means. 0 means it's not running, 1 means it's going to go running. As soon as it went from 0 to 1, we have a rather small profit. And that profit is small because of the cost of starting up. And it's several different factors that go into that cost, which I'm not going to go into detail right now, but I can if you're interested. But this illustrates even further down, we actually had a loss later on in the model by going start. The reason it started up at this cost, though, however, was it realized when it optimized that the very next period it would be making money, which would more than make up for it. The other area, which is the fun area I like, which is how you feed the model its information in terms of some constants and some other variables that you may want to change. They're illustrated here in the gray boxes. And the operation of the model, which we included for NYPA, a set of macro-driven Excel buttons to do certain functions to help you use the model more easily. So for example, if you wanted to see what it looked like with everything cleared out, let's say an operations person wanted to start from a 0 state, all they would have to do is hit the all zeros button, it would clear the whole model out. Or they could go to all ones and they could have it put everything flat out, 100% everything running every period. Or a reasonable estimate between the 2, which just is a quick estimate between when it looks like it might be profitable or not. That would be this button. But the real one is the solve the week button, which would actually go through and use the advanced Excel tools to come up with the optimal solution, which, by the way, is what we showed in the full version of this model. If anybody at NYPA is interested in seeing a demo of that, which we couldn't do here today because of security issues in terms of the computers here at NYPA, we can show you that whenever you'd like to see it. The final area is the bottom line, the money. This area is showing what the total revenue, the total variable cost, the total startup cost, fixed costs, which we were asked to leave out by NYPA in this particular version. But there is a variable that you can fill in at the top if you want to do that. It is estimated to be $5 million a year, and the model will automatically calculate that down to the 1-week period. But the total cost we came up with was $560,000, accounting for all of the costs that associated with the optimized model. Another feature we added to the model, which was not asked for by NYPA, was the ability to generate a 1-week schedule. This is fed, well, first of all, to get to, you just have to hit a tab on the bottom of the Excel model, and it will open this up automatically updated with the results of the mechanism of the model. So you see here what you can do, what an operator needs to do on any particular day for each of the 4 periods. For example, they start out on Sunday running at full out. And by the way, we use the standard definition in the industry. Red means running, green means off. That's why it looks almost intuitively reversed, but that's the way it works. Whereas if you look further down in the middle of the week, it's running flat out the middle 3 days of the week. And it doesn't always have to run at 150 megawatts. A model will adjust downward, like in this example on Saturday morning, to a lower value if that becomes the optimal solution for that particular period. and the model as a whole. Well, that takes care of the model itself and the running of it. What we did, and this was part of a request by NYPA to understand what the sensitivity are to the fixed costs, which we understand are the main areas that you can control. So you wanted to understand what you can do about that. We went ahead and used other aspects of the Excel add-ons to go ahead and do a full sensitivity analysis. This is a tool that we use for this case that plugged in numbers anywhere from the value of $0 to $220,000 and ran the model each time, coming up with what the profit would be. And as you can see, as expected, the actual profit goes in a downward slant whenever you increase the fixed cost. However, you notice something here. There's a couple of changes in the slope of the line. Those are significant, which is why we ran a second sensitivity analysis, which measured two different categories of the actual startup cost, and it shows what happens. This is the point here where we actually had it where the model decided to do two startups, like in our optimal example that I showed you in the beginning. However, once it got to about between $10,000 and $20,000, it was decided that two startups were no longer profitable, so it went to one startup, and it stayed with only one startup all the way until it got to about $205,000. And then it dropped it down to 0 startups, and that's why it went flatlined at this point, to illustrate that at that point it was no longer profitable to do a startup if that was the fixed cost, $220,000, $205,000 or more. With that in mind, I'd now like to turn this over